Okay, good afternoon, everyone. I'm Serena Goodrich of LPI, and I'd like to welcome you to the second session in this three-part series on how to become part of NASA's Planetary Sample Science community, which is sponsored by NASA and LPI. Today, we're having two presentations about NASA's Planetary Sciences Enabling Facilities Program, or PSEF, and then that will be followed by a question and answer session. If you have questions for either of the speakers, feel free to enter them into the chat at any time. And keep in mind that we won't be monitoring raised hands. So if you do have a question, you need to use the chat. After both of these presentations are over, we'll be reading the questions from the chat to the speakers. We'll be alternating between the questions in the chat and some that were submitted online ahead of time. So our first speaker today is Dr. Aaron Burton of NASA headquarters, who will be talking about how the Planetary Science Enabling Facilities Program can help the sample science community. Dr. Burton is a program scientist in the Planetary Science Division at NASA headquarters. He leads the PSEF program, as well as the Planetary Major Equipment Program and the Discovery Data Analysis Program. Previously, he conducted planetary science research within ARES, the Astromaterials Research and Exploration Division at JSC, where he studied organic geochemistry, including analysis of extraterrestrial organic materials in meteorites, along with investigations in prebiotic chemistry. Prior to his time at JSC, he was a postdoctoral fellow at the NASA Goddard Space Flight Center. He earned both his Bachelor's of Science and his PhD degrees in chemistry from Portland State University, focusing on prebiotic chemistry relevant to the origins of life. Aaron?
Thank you, Serena, and thank you for the opportunity to speak today about Planetary Science Enabling Facilities Program. If I could go ahead and get the next slide, please. So I've been, or at least when I was a lab scientist, working on I was a member of the sample science community for about 13 years or so, 14 years, studying a lot of meteorite samples in NASA's collections. And I have this slide that just kind of says there's 3 simple steps for sample science. They're easy to write down. So the first one is just have a great science idea or question. And then the second step to being a sample scientist is identifying and acquiring the samples you need. So last week, there was a great presentation by Dr. Gemma Davidson and Dr. Ryan Ziegler for information about NASA's sample collections. They talked a lot about what the different collections are, as well as tips and tricks for how to actually apply to get those samples. And then once you get your samples in hand, all you have to do to be a sample scientist is just make the measurements or experiments necessary to answer your science question. So one of the things we wanted to do with the Planetary Science Enabling Facilities program is make that step 3 easier. So we have all these great samples, whether we brought them back from missions or we've collected them from Antarctica or various locations around the world, or collected them through airplane collection programs, what have you. We have all these great samples. So what if you have a great science idea and you don't have the equipment to do it? Is there a way that we can get you access to the necessary equipment that you need? So that's what Planetary Science Enabling Facilities program was started for. And so I'll be talking about that during the first part of my during my presentation today. And then after me, Dr. Justin Simon will tell you in depth about one of our facilities in the PSEF program. Next slide, please. So we started this program. The first solicitation was in Roses 22. And kind of just a brief overview. So NASA and other federal agencies have made significant investments in facilities and instruments to support federally funded research. So we've bought a lot of fancy equipment, a lot of nice instrumentation. And so that's great if you have submitted proposals for funding. you get the instrument. And as somebody who ran a lab, it's really exciting when you get that instrument, but then you have to feed and care for it and make sure that you can have the staff you need to operate the instrument, make sure it's staying operational if you got service contracts that you need to support. And so it can require significant resources that aren't always easy to get through maintaining grants based on research grants. And so the Planetary Science Enabling Facilities Program was stood up. And so we allow proposers to submit proposals where they can request things like service contracts, technical staff, method development, that sort of thing. And so we've now had, the program is typically solicited every 2 years. So we had it in ROSES 22, and then we just had it in ROSES 24, and we're anticipating having another round of solicitations in ROSES 26. Next slide, please. And so we actually have 17 facilities that we have. And so you're going to see this information in about 3 different ways. So I don't want this to be too much of an eye chart, but here's kind of a geographic distribution of the facilities that we funded through the program. And so they range, all across the United States. The facilities listed in red on this slide are ones that we selected from ROSES 22. The facilities listed in blue are ones that we just selected in ROSES 24. Next slide, please. And so many of the planetary science enabling facilities that we have selected are really intended to support sample science. So we have 6 sample science based facilities that we selected in the 22 call, and then we have another 4 that were selected in the 2024 selection. And these awards are all in various stages of processing through the NASA Shared Services Center. So these facilities will be coming online in the near future. Next slide, please. So the first one on here, these are in an arbitrary order. So we have the Kuiper Arizona Lab for Astromaterials Analysis, or K-Alpha. The PI of that is Tom Zaga. It's located at the University of Arizona. So this facility, I apologize, my screen is very tiny. That's better. So this facility was founded in 2016 and then selected as a NASA facility in 2022. And it has a range of spatially resolved techniques going from optical microscopy down to transmission electron microscopy. And so 60% of the facility time is made available to PSD researchers, and analyses can be in person or by facility personnel, and users have to contact the lab managers for access. So for each of the facilities, this is one is a good example. We've asked the PIs to put together a quad chart, and I'll show where the website is to find all of them at the end of my presentation. But it has a quick summary of all the sort of key parameters of the facility and capabilities, and then the process for how to use the facility, and then who to get a hold of for more information. So if we can go to the next slide, please. So another facility we were able to bring online in 2022 is the GSE CARS synchrotron facility for planetary science research. This one is out of the University of Chicago and Argonne National Labs. So the PI is Antonio Lanzarotti, and this is using the Sector 13 beamline at the Advanced Photon Source. There's an X-ray microprobe that allows researchers to do X-ray fluorescence, X-ray absorption, fine structure spectroscopy, X-ray diffraction, and full field computed microtomography, as well as support for focused ion beam section preparation out of the University of New Mexico. So users are able to submit proposals here through the Advanced Photon Source General User System, and approximately 80% of the available time at these beamlines are allocated to Earth and planetary science proposals. So this one has no fees for non-proprietary experiments. And if you have questions or want to know more about what samples are appropriate, then the contact information is given in the bottom right-hand corner. Next slide, please. So we're able to establish a PSEF facility out of the Reflectance Experiment Laboratory, or RELAB, out at Brown University. The PI is Ralph Milliken. So this is a spectral reflectance and transmission data of Earth and planetary materials at visible, near, mid, and far infrared wavelengths. There's a custom bidirectional spectrometer for reflectance or transmission measurements. The viewing geometry can be changed for photometric studies. And there's an FTIR, a microscope FTIR for IR for reflectance and transmission measurements. So this facility is 100% available for community use. And analyses can be done. Either you can ship samples in, or you can come to the lab and make the measurements yourself. And anything else notable here? There's no charge to users other than cost for shipping the materials to and from the facility, or if you're going to travel there. And contact information is in the bottom right-hand corner. Next slide, please. So we also, in 2022, had the University of Texas High Resolution X-ray Computed Tomography Facility, or UTCT, come online. The PI is Romy Hanna at the University of Texas at Austin. So this facility is 2 high resolution X-ray CT scanners that are able to image millimeter to decimeter size samples, and an image analysis laboratory, so you can get data resolution down to less than 1 micron per voxel. Then there are specialized XCT capabilities here, including oversampling for better resolution on large samples, and zoom subvolume imaging for small ones. Diffraction, contrast, tomography for 3D crystallographic orientations and samples up to 2 millimeters. And then visitors are welcome to observe scanning, utilize image analysis laboratory for data exploration, visualization, and quantification, and participate in short courses in XCT, data acquisition, visualization, and analysis. And so if you want to use this facility, the contact information is in the lower right-hand corner. So you can either ship the samples or hand carry them, and the staff there will help you figure out what the best option for your sample is. And there's a 50% discount for NASA Planetary Science Division funded projects, resulting in a typical cost of $200 to $500 per sample, depending on the sample composition, et cetera. And these, for those who may not be as familiar with this technique, these are, XCT is a really cool way to make sort of 3D movies going through a sample, and, you know, identifying stones of interest inside a larger rock without having to actually physically break it, along with other research questions. So this is one we were really excited to have. I'm really excited about all of them. So don't want to misconstrue that, but I just really like videos of rocks. So next slide, please. The next facility that was also a 2022 selection is the Lunar and Planetary Institute Scanning Electron Microscope Facility. So the PI is Dr. Serena Goodrich, our host today. This is housed at the LPI. And so this is a Phenom XL desktop SEM, and it's got a carbon coater. And excuse me. Excuse me. So more than 50% of the time is available for visiting scientists and other outside users of the facility. So it's available for in-person use, and training is required. And there are no restrictions other than the required training and demonstration of competence to use the instrument. And let's see. There's currently no charge for use of the LPI SEM, and the contact information is in the lower right-hand corner. Thank you. Next slide. We also were able to select the NASA Facility for Astromaterials Research, which is a multifunctional facility that's led out of the NASA Johnson Space Center. And I won't go too much into depth here because Dr. Justin Simon is presenting after me, and we'll walk through this facility in depth. But there's a lot of good information here, and these slides will also be available. So if there's any that you want to look back at to get more information on, they'll be available in the slide set. So next slide, please. So a new selection or a new facility coming online as part of the ROSES 24 Planetary Science Enabling Facility Selections is the Wisconsin Secondary Ion Mass Spectrometer Laboratory, or WISC-SIMS. The PI is Noriko Kita at the University of Wisconsin-Madison. And so the University of Wisconsin has a Kamika IMS 1280 large magnetic sector SIMS, which has been funded by NSF and now is also supported by NASA. So it specializes, or the facility specializes in high precision stable isotope analyses of minerals at 1 to 10 microns of scale. Approximately 10% of the instrument time will be available to external NASA planetary science and broader extraterrestrial sample analysis community. And users can conduct analyses by visiting the facility in person or sending samples with documentation to the facility personnel for analysis. And then bottom left-hand corner tells us about the steps needed to actually get access to the SIMS instrument, and then how proposals are evaluated. NASA PSC funded users receive co-highest priority equal with NSF funded users, and instrument fees are discounted 50% for PSD funded researchers. For academic researchers, and contact information is in the lower right-hand corner. Next slide, please. So also in the ROSES 24 selections, so just getting up and running, is the Stony Brook Nano Infrared Spectroscopy and Imaging Facility. So this facility has a single wavelength pseudo-heterodyne near-field infrared imaging, point spectroscopy, and multispectral hyperspectral imaging from 1.4 to 16 microns at 20 nanometers per pixel spatial scales. There's an AtoCube infrared neoscope near-field imaging and spectroscopy system with a tunable laser source. Approximately 50% of the instrument time is going to be available to the community, and analyses can be conducted in person or by sending samples to the PI. And then bottom left-hand corner talks about the how to request access to the facility and how they'll be evaluated, and then contact information is in the lower right-hand corner. This instrument is currently expected to be free for use. So next slide. So we also were able to select the Livermore NASA in situ microanalysis facility out of Lawrence Livermore National Lab. The PI is Mingchong Liu. And so this is a suite of in situ microanalytical instruments with spatially resolved isotope analysis of elements across the whole periodic table. So there's 2 nanosims instruments and 1 resonance ionization mass spectrometer, or RIMS instrument, that are available as part of this facility. And then up to 25% of the instrument uptime, so approximately 50 days per mass spectrometer per year, are expected to be available to PSD funded researchers. Analyses will be performed in person, and a badge is required for lab access. And so bottom left-hand corner again has the instructions for how to use the facility. And this is one that we're still getting set up. So the website for the facility isn't ready yet, and that's why that's blank. Proposals are evaluated every 2 weeks by facility scientists for scientific merit and feasibility. And then selection priority is given, and no user fees will be charged at this facility. And then contact information again is in the lower right-hand corner. Next slide, please. And then we were able to select, also as part of ROSES 24, a noble gas facility. So this is the Rocky Mountain Noble Gas Lab for Extraterrestrial Samples. And the PI is Carolyn Crow. It's out of the University of Colorado at Boulder. So this is a noble gas facility devoted to same sample, multi-species isotopic analysis and training. The equipment is a Noble S HR 5F5M with a CO2 laser and laser ablation in situ system, advanced gas extraction line with 5 stand gas tanks. So it's expected that approximately, or at least 50% from 25 to 28 of the instrument time will be devoted to planetary science community. And this can be both in person or analyses done by facility personnel, and then facility personnel will be present during all analysis setup. And bottom left corner again has information on how to access the facility and who to contact, as well as evaluation procedures. And then bottom right hand corner has their contact information. And next slide. And then also in Rose's 24, we were able to select the Purdue Resources Empowering Coordinated Investigations for Sample Exploration. The PI is Michelle Thompson out of Purdue University. So this is a coordinated analysis of planetary materials and analogs. So there's a lot of different techniques and instruments and equipment that are being made available to the community through this facility. So there are 13 different labs that are being made available to outside users. And these include solar system, isotopes and chronology, coordinated composition, microstructure, and magnetism, and then bridging the gap between remote observations and laboratory science. It's expected that across the whole facility, around 3,000 hours of annual instrument time will be made available, and users can visit in person or send samples for analysis. So again, the bottom left-hand corner has information on how to access the community, how proposals are evaluated. And it's currently expected that there will be no cost to users through the facility, although if you're going to travel there to analyze it, to have samples analyzed and physically be there, you have to pay for your own travel costs. And then contact information is in the lower right-hand corner. Next slide, please. So of the 16, 17, it's hard for me to count past 10. But for the 17-ish facilities, I guess the first 11 that we just talked about were ones that have an obvious and clear tie to sample science and sample analysis, and that's the focus of the workshop. But I did want to mention, because many of our researchers that do sample science are also interested in other planetary science division subjects, so that are not necessarily just the analysis of extraterrestrial samples. So we also have a handful of other facilities. So next slide, please. So we have the Ames Vertical Gun Range at the NASA Ames Research Center is here. And so this is a multiple hypervelocity impact guns in this facility that allow studying impact processes. And so again, as with the other quad charts, this has how to use the facility in the lower left-hand corner, who to contact in the lower right-hand corner. But this is a Rose's 24 selection we were able to make. Next slide, please. The Planetary Cloud and Aerosol Research Facility. This is led out of JPL by Mike Pocken. So this is a facility that's in the process of being built and commissioned, but will allow researchers to do various gas compositions and study clouds and aerosols in a way that makes them relevant to a lot of different planetary atmospheres that we weren't able to previously simulate on Earth. So this facility should be coming online hopefully in the next year or so. And again, we have all the contact information. Next slide, please. So we also have the Planetary Aeolian Laboratory at NASA Ames. So this was a Rose's 22 selection. And so the PI is Haley Cummings. This is at the NASA Ames Research Center. So the Planetary Aeolian Lab allows us to simulate aeolian processes under planetary atmospheric environments in a very large chamber. So this facility has been around for a while, but we've got it in the PSEF portfolio, and some upgrades are being added. And so we're excited about this facility continuing into the future and being available for the planetary science community. Next slide, please. We also have CAVION, which is a kilo electron volt irradiation facility for space science. So this is, the PI is Kathy Dukes out of the University of Virginia. And so this is a facility where we can study space weathering and other techniques. And this facility was selected in ROSES 22, but it's also got some construction going on and is in the process of getting up and running. And again, contact information and how to request time is listed here. Next slide, please. We also have, this was a ROSES 24 selection, but the Colorado Dust Accelerator Facility, PI is Tobin Munsat at University of Colorado. So this is a 3 megavolt linear accelerator for hypervelocity impacts. So it can study dust grains impacting into substrates. And then there's a added capability that's being developed to be able to accelerate ice particles or ice grains into different substrates. And so hopefully this facility will be online in the near future. Next slide. So also in ROSES 24, we were able to select the in situ carbon evolution experiments facility. PI is Andrew Mattiota at NASA Ames. So this is a facility dedicated to replicating conditions relevant to planetary science. So you can do basically organic chemistry under different radiation conditions and characterize the products of those. So this is one that will hopefully be online, available to the community soon. Next slide. And so here's the, we have a website off of science.nasa.gov. There's a tab for researchers, and then there's the planetary science enabling facilities. So all the ROSES 22 selections are listed on there, and they have links to their quad charts to get more information. There's also, we'll get the ROSES 24 ones up there soon. But that's kind of a one-stop shop for how to get to the facilities. This is linked to in Appendix C.1 of ROSES, so the Planetary Science Division research solicitation. Next slide. So if you have questions about the PSEF, any of the facilities or the program in general, you can, again, go to the website and contact the leaders of the facility or me. And if you're not sure what facility you might need or what facility might be able to help you, you can always contact me. And I know it's a lot of information to take in, and I didn't want to go too in depth because, you know, each one of those facilities could really, you know, merit its own half-hour presentation. But we've got a range of facilities, and we allow the facilities to kind of structure their facility management plan in their own way with their own kind of user fees and schedules for what works for the facility. But if you have any thoughts about the program, I welcome any feedback people might have. And of course, I'll stick around till after Justin's presentation if there are any questions that I can answer today.